Hi guys, welcome to our lecture on the extreme values of a function. In this lecture, we are going to discuss about these extreme values. Extreme in the sense it can be a maximum or minimum. And especially in this lecture, we will discuss the polynomial functions. Okay, a polynomial function may have a maximum value or may have a minimum value, or it may not have any maximum or minimum. While we are talking the maximum values or minimum values, we may have a question in our mind. See, suppose your curve is like this. Suppose your curve is like this. This is the maximum value. This is the maximum value, and this will be the minimum value. So in the restricted domain, we are getting our minimum and the maximum value. Suppose our curve is like this, and we will be having so many maximum and the minimum in different intervals. If we try to find the maximum or minimum values for the whole curve, which we call as a global maximum or minimum, if it is in a particular, then it will be a local maxima and minimum. In this lecture, we are going to discuss about the local maxima and the minimum. See, suppose we have a function f of x. How to find the maxima and the minima for a function? Let me describe the steps. First, find your first derivative f dash of x. And then put your f dash of x is equal 0. So what may be the f dash of x? F dash of x we call it as y. We find the derivative of y, that is dy by dx. The derivative we are here equal it to 0, which means that here we are finding the horizontal tangents. If the slope is equal 0, that line becomes the horizontal tangent for the given curve. And hence, if you have such a curve, then this point here we are having a horizontal tangent in which the dy by dx is equal 0. So at this point, definitely we will be having a minimum value. That's our idea behind finding the f dash of x and equating that to 0. Okay. Now, second one, find f double dash of x is equal f double dash of x. Here, this f dash of x is equal 0, we are equating, right? While solving, we will be getting the x values. So find our x values. After finding the x values, find the f double dash of x here. That is, from here, find f double dash of x. That is the second derivative of the function. And then put your x values over here. So say for example, substitute, take it as x is equal c, and after substituting, we will be getting f double dash of c. The condition is, if this f double dash of c is greater than 0, the point you have substituted x is equal c is a minimum point. And if this f double dash of c is less than 0, which implies the point x is equal to c is a maximum point. If the derivative f double dash of c is equal 0, which implies there is no maximum and there is no minimum. That is, it doesn't possess any maximum or the minimum. Okay. By utilizing these steps, we are going to find the extreme values of this function. Y is equal to x power 3 minus 9x power 2 plus 12x minus 3. Minimum of this function. Y is equal to x power 3 minus 9x power 2 plus 12x minus 3. Let's follow the steps what we are having over here. So let us find the y dash, which we called as the derivative dy by dx. Don't forget, we are differentiating here with respect to x. And hence, this is 2. The derivative of x power 3 is 3x power 2 minus 9. The derivative of x power 2 is 2x plus 12. The derivative of x is 1 minus the derivative of 3. 3 is a constant. The derivative of a constant is 0. Let's simplify the y dash. It is 6x power 2 minus 18x plus 12. So as per our steps, if you are having that f of x is equal y, substitute equal 0, that is put equal 0, make that equal to 0. So if y dash is equal 0, then 6x power 2 minus 18x plus 12 is equal to 0. Take a 6 as common, so x power 2 minus 3x plus 2 times 6 is 12, right? So it is 2 is equal 0. Absolutely, this 6 cannot be is equal to 0. So the value inside the bracket should be is equal to 0. Okay. So how to solve this one, please? Yes, exactly. We have to split, we have to factorize this. How to factorize? Good. It is 2. Let's split this 2 into 2 parts. Yes, good. It is 1 into 2 is 2. Here it is minus 3, so yes, minus and minus. Good. This is x minus 1 into, here it is x minus 2, which is equal to 0. So x is equal to 1, x is equal to 2. So now we are getting the two values for x is equal to 1 and x is equal to 2. And these 2 points, the x is equal to 1 and the x is equal to 2, are called the stationary points. Or sometimes it is called critical points. The stationary points or the critical points. Let's find the second derivative of the function y. Already we found y dash and hence go for y double dash. We call the y double dash as d square y by dx square, the second derivative. Find our function from here. It is 6. It is x power 2. We have to find the differentiation for x power 2. What is the differentiation for x power 2? Yes, you are correct. Yes, exactly, 2x. Minus, what is the differentiation over here? Minus 18x? Good, minus 18. And this plus 12 becomes 0 because, good, the derivative of a constant is 0. Now, substitute the x values. What do you find here? What do you find here? So let me split it into 2 parts for computational easiness. So this is for x is equal to 1 and this is for x is equal to 2. So y double dash at x is equal to 1 becomes 6 into this is at x is equal to 1. Okay, please put it. So at x is equal to 1, our y double dash become 6 into 2. This is totally 12, right? So let me write it as 12. 12 into, in place of x, it is 1 minus 18, which is equal to 12 minus 18, that is minus 6, which is less than 0. So if f double dash of c is less than 0, the point you have substituted is a maximum point. So the point what we have substituted as x is equal to 1 is a maximum point. Go to x is equal to 2. So at x is equal to 2, y double dash is equal, from here 6 into 12, 6 into 2, it is 12, in place of x it is 2 minus 18, which is equal to 12 into 2, it is 24 minus 18, which is 18, which is equal to 6, correct? Yeah, 6, which is greater than 0. If it is greater than 0, if f double dash of c is greater than 0, then the point what we have substituted is a minimum point, and hence x is equal to 2 is a minimum point. But still our objective hasn't fulfilled yet. Our objective is to find the extreme values of a function. that is the maximum or the minimum or both of the function f of x, which is y is equal to x power 3 minus 9x power 2 plus 12x minus 3. So let's substitute this value x is equal to 1 here, that is in our function. So at x is equal 1, y is equal, this is 2 into 1 power 3 minus 9 into 1 power 2 plus 12 into 1 minus 3, which is equal to, it is around 2 minus 9 plus 12 minus 3. Yeah, 12 cancel and we left with 2. And let's consider over here, and at x is equal to 2, find the value of our function y. This is 2 into 2 power 3 minus 9 into 2 power 2 plus 12 into 2 minus 3, which is equal to 2 into 8 minus 9 into 4 plus 12 into 2 minus 3, which is equal to 2 into 18, it is around 16, 9 into 4, that is 36, plus this is 24 minus 3. So here it is around 40, here it is 39, and hence the solution is 1. See, as we already discussed earlier, this x is equal to 2, where that y double dash of c is greater than 0 is a minimum point, and hence it gives the minimum value 1. X is equal to 1, for which the y double dash at 1 is less than 0, that is a negative, gives the x is equal to 1 the maximum point, and hence while substituting in our function, this gives the maximum value. So this is the constant steps we are following in order to find the maxima and minima, that is the extreme values of a function. Let's practice a little more problems on this extreme values function. Thanks for listening. We will be meeting in the next lecture. Thank you and bye bye.